Good evening, everybody. A very warm welcome to Kaizen Central. Delighted to have you with us today. And also delighted to welcome Ian Higgins from Less Common Metals, who's come here to talk about, I suspect it's not a very well-known subject, but it is absolutely vital in terms of the security of our economy, in terms of electric vehicles, in terms of just about anything you care to mention, rare earth metals and the permanent magnets they help to produce. I'm going to share very quickly. This is Ian Higgins' company, Less Common Metals. And that very much says what it does on the tin: a world leader in the manufacture and supply of complex alloy systems and metals, specialists in those based on rare earth elements. And Ian, first of all, thank you very much indeed for joining us. Hello, Georgia from Less Common Metals as well. Thank you very much for making this possible. Very much appreciate it. Ian, tell me, please, about the situation. Well, let's number one. I've made some claims about what rare earth metals do. Please, you better explain what they do, because you'll do far better than I will, and their applications, not only in the technology of today, but the technology of the future.
Okay, well, far and away, the most interesting application for rare earth metals today is as an essential constituent of rare earth permanent magnets. And the key feature of these magnets is they are extraordinarily strong, several orders of magnitude stronger than the kind of magnets you may be used to in terms of fridge magnets, or other basic things you might play around as in your children's toy sets. These are extremely strong. As I say, they're permanent, so they are resistant to losing their magnetization, and they have a range of fascinating applications. Traditionally, you would find rare earth permanent magnets in the hard disk drive of your computer, particularly your laptop, and it really was the permanent magnet technology that allowed us to actually go to portable electronic devices, portable computers, laptops, because it allowed for that miniaturization of components. We then see rare earth magnets appearing in a whole range of different sensors, chemical couplings, and then DC motors. And I think most people understand that motors require a magnet of some sort or other. The rare earth based ones mean that the motors can be made very small indeed, very efficient. The saving in weight is attractive certainly for transport applications. So we see a lot of DC motors in automotive, and just looking around the car, it's quite common to have easily a dozen or more DC motors, and relatively simple things such as the seats, the windows, etc. And then, of course, we have what the government likes to call the electric revolution, where they're driving the electrical revolution. But now we're seeing the rare earth magnets cropping up in the drivetrain for electric vehicles or hybrid electric vehicles. And then, if that's not exciting enough, we also get the rare earth magnets in the more modern wind power generators. And these are the ones where you want to operate without a gearbox. The gearbox is heavy, it's complicated, it's prone to breaking down. If you stick your wind farm in the middle of the Irish Sea, like we got them just up the coast from us at Less Common Metals, the last thing you want to do is to try and have to get out to the wind farm to maintain something that's breaking down a lot. Also, with the rare earth permanent magnet-based wind generation, you can operate at a much wider range of wind speeds than you can if you have to use a gearbox or a more conventional system. I think one of the key messages about rare earths is that rare earth permanent magnets is there are possibly alternatives, but from a technical point of view alone, they're not as good.
Okay, so Less Common Metals, tell us a little bit about the company. How long have you been dealing with these more, I'll use the word exotic metals and alloys that you produce?
Okay, well, Less Common Metals was born out of another company in Northwest England called Johnson Matthey Rare Earth Products, which operated from, well, certainly before my time, and really its history stretched back to the 1960s, working in rare earths. Less Common Metals was founded in 1992, primarily focused on making alloys. The rare earth permanent magnets we talk about, they're made out of alloys containing rare earths and some non-rare earths. The alloys are made pretty much like any other metal-based alloy system by melting and casting raw materials. Less Common Metals does that. So we effectively sit somewhere midstream in the supply chain, as much as we take raw materials in the form of metals, melt them and cast them into alloys, which are then supplied to somebody who does the magnet making side of the process. Just to add a little bit more about what Less Common Metals does, in the last 5 years, we've also added another process, and that is we now make our own metals. So our raw materials, we still buy in some metals, but some of our key raw materials for the rare earth permanent magnet chain are the oxides, rare earth oxides, which we process through into metals. And that's pretty much a unique capability for us in the UK, that nobody really outside of China or Southeast Asia does that today, apart from Less Common Metals.
That makes you something of a world leader, as your website suggests. Now, where do you get your raw materials from? According to some of the news stories we read, it almost feels like China's cornered the market. But China's not the only place where you can get the raw material for these rare earth and permanent magnets.
Well, in terms of actual production, particularly production of any sort of downstream product, China does wholly dominate, and we could probably come on to the reasons why that is in a bit. As far as LCM goes, we buy a lot of raw materials from China. We always have done. But I mentioned this new activity which we brought in 5 years ago now, which was making the metals. One of the key reasons for doing that, as well as giving us the unique processing capability, it also did give us some more options. Because whereas there's not really a lot of option for buying rare earth metals outside of China, we can buy the rare earth oxides from various other sources, such as Australia, Malaysia, for example. And we then can make at least some of our products with non-Chinese material. Excuse me, I've got to sneeze. Okay.
So tell us a little bit about the geopolitical element of all this. We know that the United States actually lost a great deal of its capacity because it was rather, what's the word I should use? It was sideswiped by the Chinese, who came in and sometimes secretly bought into their production capacity and then took it back to China.
Yeah, well, I must admit, I wouldn't really present it in that way. The American companies, the American magnet companies that ended up in China, at least one of them was not what you call cutting edge. And I think you have to be blunt about this, but the way China really established dominance, well, first of all, they do have quite a decent geological advantage, in as much as there are some very low cost deposits of rare earths in China, some very easy to access and work deposits of rare earths, which helps. The Chinese leaders recognized the strategic value of rare earths many, many years ago, to the point that every 5-year plan in China does specifically refer to rare earths and about the policies for developing the industry for the benefit of Chinese economy. There has been quite a lot of joined up strategic thinking. It hasn't all gone to plan, and one of the fallacies that everything in China runs very, very efficiently, and they've got this great, fantastic system where they've taken over the world. They've kept things moving in the right way in terms of developing the industry, and now they've created a fully joined up, holistic industry which has all the stages of the supply chain. They're reasonably well coordinated. They've benefited from the central planned economy. The places can simply be closed down or instructed to move somewhere else, or forced to join in with somebody else. everything's reasonably well joined up. The government supports the industry massively in terms of rare earth enterprise zones, in terms of research and development, funding research and development and making the results available free of charge. And it also supports companies working in supply chain by way of VAT rebates, which means that the price which people are led to believe is the price for intermediate rare earth products is actually overinflated, because in China those prices are discounted by a VAT rebate. And then on certain enterprise zones in China, the local authorities give further discounts on raw materials. So I'm not sure this is answering the question correctly, but I think it's all related, is that today's China's dominance in the integrated supply chain, and certainly the supply of magnets globally, is pretty much total, driven by a lot of things. Now there are negatives as well in there. Of course, there have been the Chinese rare earth industry traditionally has had environmental issues associated with it, health and safety issues. It's fair to say that pre-COVID standards were being improved quite dramatically, but the position China finds itself in today has certainly been driven by a historical poor regard for health and safety in some cases. So that's really how China's got what it is today. And the reason I wanted to correct you a bit on the comment about buying into American technology is that China has, as I say, invested massively R&D, to the point that if you do any sort of patent search today, you'll find that most patents associated rare earths, either applications or processing technologies, come from China. The kind of research institutes they have in China are actually very impressive, and the level of the work that's being done is actually very, very good indeed. So I'd be careful on this narrative of they've simply come in and monstered somebody else's technology.
I was actually more thinking that they weren't nicking the technology, they were actually undermining the American rare earth sector and setting it back quite a ways, because the actual processing of rare earths is, as I understand it, extraordinarily expensive and involved. It's not something you can just say, we're going to start, we're going to do this in a couple of years' time. It actually takes an awful lot of effort and energy to do it. And so once you've lost that capacity, and America did lose some of that capacity when China moved the companies back to China, it meant that they actually, America was put behind the curve. And again, I'm going from that article for the Foreign Policy Research Institute. They may have overcooked the story.
Yes, the processing stages of rare earths are all specialist. If I can just run you through the stages required from having a rare earth in a mineral through to having a magnet. Your first stage would be to mine the mineral, and typically the rare earths occur in very low levels of deposits. An economic rare earth deposit, depending on the kind of split of rare earths, can be anything from 0.1% rare earths up to maybe just 1 or 2% rare earth. These are the deposits that are worked today. So the first stage is, I think, the technology for that are relatively accessible globally, because that's kind of mineral processing, gravimetric separation, maybe magnetic separation, spirals, a mixture of slurry-based processing and dry processing to give you a feed where the rare earth mineral is concentrated. But from then on, it's very specialist kind of processing. The first chemical stage is what's commonly called cracking. The rare earths occur tightly chemically bound within the mineral, so there's a requirement to attack with strong reagents under some very severe conditions. That's technology which has been developed in China. It is available outside of China, and a few research institutes, particularly in Canada and Australia, are very active in terms of developing and enhancing that kind of technology. The next stage after that is to actually separate individual rare earths. Again, now China has taken that process. It's called, the waste rare earths are separated in a process called solvent extraction. And it's just based on the idea that you have two immiscible liquids. If you think of an oil-water mix and you put them into a glass beaker and you shake them all up, and then if you leave them to stand, they separate out because the two liquids don't mix with each other. And solvent extraction works on the idea that the rare earths will preferably be more soluble in one of those liquids than the other. And that's the basic principle. And there's an awful lot of very clever engineering that goes on to turn that into an industrial process, because the difference in solubility is very, very small. So you can't just have one beaker, you have hundreds and hundreds of them all in series, so that progressively you start to concentrate up one rare earth, preferably to another one. That technology was actually developed here in the UK at Harwell, believe it or not, for the nuclear industry. It was licensed to the Americans, and it was licensed to the French company Rhône-Poulenc. And for many years, the only Western world person operating that technology was Rhône-Poulenc in a factory in La Rochelle in the west of France. China has really focused massively on that technology and developed it to the base that the solvent extraction plants in China are now more advanced than anywhere else in the world. And pretty much, if we look outside of China, anybody doing rare earth separation, more often than not, they've started off by accessing Chinese technology. Not completely, not exclusively, but most have. The next stage is the state where I'm coming now to what LCM does, which makes metals. And I said we brought this process in 5 years ago. How do we do that? Simple. We actually got a team of Chinese engineers who came over and spent 4 months working in our factory. Wasn't simple at all, but that's how it was done, because massively know-how driven process. I say it's very similar to brewing or specialist baking. You can have all the manuals in the world without having the people, the hands-on experience who know exactly how to do this. You struggle, and we transfer the know-how from China into LCM. Alloy making, what we do, again, the people in Japan doing it, but nobody else apart from us. And then magnet making, the best magnet making plants in the world today are in China. Unfortunately, that's an unfortunate fact, and that is a reflection of the level of investment that has been made at a strategic level in the Chinese industry. So there are lots of intense processes, a lot of know-how, a lot of technology. And frankly, we in the West, we've all sat around on our hands while the Chinese have made all these advances over the last 30 plus years.
Yeah, it feels like it, doesn't it? Tell us about the project that I believe you're involved in, which is a European project funded by Horizon 2020. SECRETES, Secure European Critical Rare Earth Elements Project. What is that trying to achieve?
Okay. Well, fundamentally, it's trying to set up an all-European supply chain. So I took you through those 6 steps. It's really trying to recreate all of those 6 steps exclusively in Europe. Now, because the first thing you need is a source of raw material. And I spoke before about mining and mineral processing. SECRETES starts somewhere else. We're not really blessed with any, well, some people disagree with me there, but rare earth prospects in Europe, mine prospects, there are few and far between. There are a couple who are claiming that they believe they can. Who knows? They may actually turn out to be right. But SECRETES starts with fertilizer production. It starts with the Norwegian company Yara, one of the world's biggest producers of phosphate-based fertilizers, and they process a mineral called apatite, essentially calcium phosphate. And they process it through a series of chemical digestion steps, precipitations, everything else, and they end up with a phosphate-based fertilizer that they sell globally. Now, that apatite that they start with often contains rare earths. Not a lot, say maybe up to about 0.6% rare earth. There may be none. It depends where they buy their apatites from. They buy them all over the world. But you can have 0.6% rare earth. It's a pretty small amount. But the volume of fertilizer they're making is enormous. So at the moment, they simply leave the rare earth in the final fertilizer. It doesn't have any negative properties on the final fertilizers. They simply leave it. What they've done in SECRETES is they have installed a process where they divert the mother liquor partway through the process. They strip out the rare earths, and then they reintroduce the mother liquor into the mother liquor into the main supply chain. That then is a source of rare earths, and a pretty decent volume source of rare earths. And most importantly, because it's just a bit of a sidearm to the main processing, a low-cost source of rare earths. SECRETES then takes through other process stages, including what LCM does, making metals, making alloys. So when I talk about our developments in metal making, we've been very fortunate to benefit from that support and been able to enhance, improve our program, our metal making at LCM, making alloys. And then the alloys we make go to Europe's largest producer of magnets, and they will make specialist magnets. So the idea is they will then market magnets in Europe that come from an all-European supply chain.
So what chance do you think that there is of actually developing this all European? I mean, do you see a future where LCM will actually get enough from this that you will end your trade with China?
I don't think you'll ever get a situation where the rare earth industry ends its involvement with China, and I'm not even sure we necessarily want to get to that stage. What we want is a much more balanced industry, where instead of getting, say, 95% plus of our magnets from China, maybe it's something like 50%, or well, pick a number, 40. There are decent options from out there of good quality, viable magnets. It's not just China. And I think that's what we're all striving for, is balance. Now, will we get an all-European supply chain? It's difficult to say, because we need every stage of that process to make sense and be economically viable. However, there's no doubt that the Secrets project, and yeah, we all pronounce it both ways as well, will give improvements in every stage of the supply chain. So even if, for example, it's not a European primary source, it may be a Canadian source or an Australian source. It takes us closer to getting the goal, which is a non-Chinese supply chain.
That obviously, given the tensions and the worries about US-China relations, and then there's Taiwan and all that sort of thing. This is obviously, as I said at the start of the conversation, it's geopolitical. It is about security. It's about defense and all of that. And it's about keeping your business going at the same time, isn't it? You've got to, you can't be vulnerable to changes in political relations between two of the biggest nations on earth.
Absolutely correct. Yeah, you're totally right there, Nick. And it's not just about keeping LCM's business going. Let's talk about Western world industrial businesses in total. Yeah, we all know we're moving towards electric vehicles. We want more wind turbines. If we look at Chinese policy, especially the Made in China 2025 policy document that is widely available now, it very clearly states China's intention to move further downstream. Not particularly fussed about selling magnets globally. They actually want to sell the cars and the windmills and the washing machines that contain the magnets. They want to sell the consumer goods. Now, you can't blame them for wanting to do that, of course, but what impact does that have on all our industries? I'm a bit of a simple soul when it comes to economics. I never ever understood how you actually can drive economies if someone doesn't add value. And to me, manufacturing is how you add value. And unless we take intervention like Secrets, programs which try to stimulate alternatives, we're just going to lose more and more of our manufacturing base, and we'll all find ourselves buying all our consumer goods out of China.
Well, there is a rather terrifying prospect. Ram Shankar, you put your hand up.
Thank you, Nick. Thank you, Ian. That was quite eye-opening and fascinating. And not at all surprising, given that how much I follow the geopolitical tension between China and my homeland, India, where I come from, and it's not surprising at all. Now, we are doing, as a country, as a collective, we're doing numerous things to try and bring back manufacturing, bring this back from China, do this, do that. But no matter what we do, unless and until we change our buying habits, right from the individuals, right down to all the corporates and companies, we're not going to be able to make any change, no matter how hard we try and incentivize it in government schemes. How do you suggest we go about changing the buying habits of the people? Because if nobody's going to buy it, there's no point in making it. So that has to be changed. And how do you propose we go about doing that before anything else?
I really thank you for asking the question, because it's hugely relevant. You're absolutely correct. The only way I see a material change from the consumer side is if it comes from the actual end consumers. And the analogy I'm going to give you there is Nike. Nike having 8-year-old children in Bangladesh stitching footballs. And I mean, I don't know, but I would imagine that when Nike senior executives met, they would say, yeah, we know this is terrible. We need a plan, and we must try to get away from this and that. And they probably had some plans in place, but it wasn't until there was a realization from the general public and a public outcry that suddenly those plans were accelerated dramatically and massively, and they started doing the right thing. And I think, yeah, for me, an exercise like this is great, just trying to pass the word out about how vulnerable we are on Chinese industry today. Now the blunt truth is that we can't make magnets that are as cheap as Chinese magnets. If we did everything for free, and if the magnet maker did everything for free, we may just about get a magnet that's somewhere close to a Chinese price. That's the hard bit and truth. Now, when you're an automotive company and you're competing with 5 other automotive companies, it's very hard for you to ignore that. It's very hard for you in isolation to take the moral high ground and say, well, I'm going to strategically do something different. If you're selling your cars or your washing machines, and the person buying it says, where have those magnets come from? Now, have they come from a fully traceable, auditable supply chain where full levels of environmental, social governance standards are being adhered to? Can you demonstrate that? Can you audit it? Can you show me your independent third-party auditor that's actually said that there's none of the problematic aspects of processing that have happened in China in the past? Strategically, I think I would rather buy my car with magnets that have been made using a non-Chinese supply chain. Can you demonstrate that? But the big push for that has got to come, A, from consumers, and then the next thing, what can governments do? It's one of those classic ones where we can't, it won't happen if we try and leave it to the free market, I'm afraid. It just, I'm sorry I'm delving into deep politics now, but we're probably where we are today because of the way free markets have evolved in the last 2 decades.
Yeah, I don't think you'll find any gainsayers on this group. I mean, the sort of rather laissez-faire, let it rip free market, as you said yourself. The world stood by while China was doing this. People saw it happening and thought, okay. And of course, it is politicians that have to give the lead. Roy Spencer.
Yeah, thanks, Ian. What opportunities are there to recycle? I mean, a lot of the rare earths that we use in our laptops, our mobile phones. I mean, if I look in my loft, I'll probably find 3 or 4 laptops, and I won't be that unusual in that respect. I've probably got 4 or 5 mobile phones lying around, which are of no use to me anymore. Are there opportunities there to recycle from that? I mean, that Mount Recycle More that they built next to the G7 thing was absolutely wonderful. But I just wonder how practical a point it actually made in terms of what you can recycle. Because I think the fertilizer example is a wonderful example of how the waste from one stream can feed another stream. And that's a brilliant bit of circular economy.
Okay, well, let's start with the bad news first of all. Is today recycling of rare earth magnets is very poor indeed. The reason it's very poor is that most incentives to recycle are based on weight, like a requirement to recycle X% by weight of a car, for example. Or if we take your example, the hard disk drives, the magnets, the permanent magnets as hard disk drives, there'll probably be 2. And they'll each weigh about 15 grams. They'll be coated probably with nickel. They're probably about, well, they're not probably, they will be about 3 millimeters thick in total, including the coating. And the sheer amount of labor required to get at those magnets means that they're not one of the materials where there's historically been focused on recycling. That's the bad bit out of the way. And the other bad bit is that people designing the components have never really designed for recycling. But let's go to the good bits now. First of all, that is happening more. There is more of an incentive, more of a drive. certainly, and there've been some quite useful European projects which have really given folks that to design for recycling, to design so you can get out the magnets, get them out. And the other really bit of good news is here in the UK, that we actually have some of the world's best technology developed here in the UK for recovering the rare earths from permanent magnets. And that's technology that was developed at Birmingham University. Birmingham University is one of the global leaders in magnet technology, and they have specifically focused in the last few years on recovery of magnets from scrap, recovery of rare earths from scrap magnets, and they are now looking to commercialize that process. So their biggest challenge is going to be getting enough raw material in the form of spent magnets accessible to them to really mount a viable business. And it's one that will probably take time, as the kind of components that are going out today into the market, so the ones that come back into the recycling loop in say 10 or 15 years time. But I'm convinced that with the right level of support, they keep developing their model, they will have an elegant recycling business here in the UK.
Where do you think the government could actually help in this? I mean, clearly the Chinese government play a significant role in enabling them to penetrate the market, and they're not driven to the same degree by shareholder dividends. You know, they've got the longer game in view. I mean, what kind of support could a UK government give, and where would it be most appropriate?
Well, first of all, if I start with the fundamental supply, I do have high hopes about the fertilizer route, things like that, but it won't be the full answer by any means. There won't be enough material, I suspect, even though there are good volumes. There's probably not enough for everything we need. I would say that for the UK supply chain, it's likely that we're going to have to secure some sort of partnership with a company it will be from overseas, and so we look at friendly nations, and for us in the UK, the obvious ones would be Australia or Canada. There's also the United States, because they are so focused pretty much on what they're doing internally. There's so much of a US-driven drive, but of course, in theory, we could also have collaboration with America. So what can the government do? I think the first thing they could do is really drive those relationships at a government-to-government level. Make sure that the deposits of interest, the primary rare earth deposits of interest, are secured for the benefit of UK PLC. And actually realised when I said Australia and Canada, I kind of missed out Africa as well. There are some deposits in Africa which potentially could also be of use. So the first thing, UK government, diplomatic support, maybe even financial support. Why should a processor in Australia or a miner in Australia who's got a rare earth deposit, what's going to make them want to feed it into a UK supply chain? Well, if there's a certain level of UK support to get their project up and running, then that helps to secure the raw material. Here in the UK, we've got a lot of the infrastructure we need. I mentioned at one time that the process of separating rare earths was developed at Harwell. We have a very strong, well-developed chemical infrastructure in the UK, so we have access to reagents, and the technology that we need is available. Support with licensing, support with permitting. Another big one, a couple of the process stages, particularly what we do at LCM, are energy intensive, and they're electric processes. So what we need is low carbon, low cost power. We're paying, and forgive me, I have to talk in cents because we do all our kind of cost modeling in US cents. It's just a global thing, really. Today, we're averaging something like 17 cents per kilowatt hour for our electricity. If we sat in China, we're paying 5 cents per kilowatt hour on a dedicated feed. So we've got a threefold disadvantage straight away in our power costs. Now, we're not saying let's get copious amounts of dirty coal-fired power in, but we're the world leader in wind farms at the moment. Let's exploit that for the benefit of UK industry. Let's get some of that wind power into specialist areas where we have low-cost feed. And they don't just support our rare earth industry. There are plenty of other industries in the UK which are energy intensive, and we could really lever on our wind power and start to get some energy intensive industries set up efficiently. That's just a couple of examples. But in fairness to the government, I would say they are looking strategically at certain aspects of the magnet supply chain at the moment. And at Less Common Metals, we've benefited. We've been awarded funding by the government to conduct 2 feasibility studies. The first one on the supply chain, which does require us to make the kind of recommendations you just asked about. And the second one, we're also looking at a feasibility study on actually getting a magnet plant up and running in the UK. What would the market look like for a magnet plant once it was up and running in 3 to 5 years' time? What industries, what kind of magnets, what would this kind of operating cost, the capital cost, what would the footprint lay like, designing the factory really, and ultimately from that we want to get a business case out, and a business case that's sufficiently attractive that will get the necessary support and investment to get it up and running. Again, that might require an aspect of government help.
Thank you. If I can ask Graham Cooper, who's had his hand up. Graham, you have the floor.
Thank you, Nick. Really fascinating talk here, and thanks very much for that. I have a question about rare earths generally. You're talking a lot about magnets. Are they not also used in batteries and fuel cells? Not really, no. I'll show you nickel metal hydride batteries. They're the more old-fashioned technology. They do use rare earth. The metal in nickel metal hydride is a rare earth, but pretty much everybody in electric vehicles now have gone on to lithium-ion systems, which don't contain rare earths. Okay, thank you.
Steve.
Don't they also use rare earths in hydrogen storage systems?
You can do, yes. You have some which, yeah.
But I'm not sure how much popular hydrogen-powered vehicles use these sort of things. I've used them in the past for technical projects,
yeah.
And their advantage is that they are very safe. In other words, whereas if you took a big bottle of hydrogen and rammed it into something, there'd probably be an explosion. Whereas the sort of the rare earth systems, you can just throw them into a fire and they won't explode or anything. So is that an area that you work in as well, or is it strictly the magnets that you do?
Oh no, we make alloys that go into hydrogen storage. Now, some of those alloys contain rare earths, some of them don't, and I would be fraudulent if I would claim to be an expert on what advantages there are for the non-rare earth systems over the rare earth systems. So yes, to answer your basic question, you can use rare earth based alloys for hydrogen storage.
Oh. And is that business increasing, or is it?
Yes.
Okay, good.
Yeah, I think that obviously the government seems to be putting its lending its shoulder to blue hydrogen, but everybody else is saying that green hydrogen is the future. But whichever way they go, somebody's got to store it, and they've got to store it safely. Ian, I wonder if you sort of taking a step back from your own business and looking out across UK manufacturing, if you were about to, get into manufacturing or adapt your manufacturing processes, are there any opportunities that you see out there for companies who are looking for new ways to get involved in this particular supply chain that you're trying to develop in Europe?
Opportunities. Well, the raw material is the building block. It's like the foundation you build the house on. So once you've secured that feed of raw material, then yes, I think there are a number of opportunities, and we probably have to be realistic and say we're never going to set up a supply chain that is totally competitive on costs with what China do. Yeah, we pay our people more, we have a better standard of living, and some of the less savoury aspects of Chinese industry we couldn't do it even if people wanted to do over here. So a simple sort of me too copy exact business model is unlikely to really get very far. So we have to look at innovation, and there are scope for innovation, particularly on the way the rare earths are separated. And I described solvent extraction in basic terms. There's a lot of scope in that process alone for
different variants which will efficiently separate rare earths. There are a number of other methods out there for separating rare earths, and they can be further developed. What we do at LTM metal making. Now, the metal making process is strange because from a pure economic point of view, you won't get anything better. It's a very low cost way of converting. The method we use is a very low cost way of converting oxides into metal, exactly the same way that aluminium is made globally at the moment. However, it is a process which inevitably produces CO2 as a byproduct. So the carbon footprint of the process is high. And it may be that there are other technologies which will make metals, and it may be that you can take one of them to a point where it's sufficiently economically attractive that the huge advantage of not generating CO2 is justified, if you like. Again, the alloys we make, there are different ways of making alloys, and fundamentally there are different ways of making magnets. And I talk about scoping this magnet plant. We're looking as much as possible at innovation in this magnet plant. Different ways of making magnets, ways of saving costs, ways of avoiding using the more expensive rare earths that go into some of these magnets, ways of making magnets smaller, more complex shapes, which therefore mean that the magnetic flux is better utilized. We're hoping to talk with design engineers for motors who could say, look, if you had a complete blank sheet of paper and you could use any shape of magnet you want, what would you like to see? And let's see how we can develop those concepts. So yeah, I mean, as with any threat, yeah, there are opportunities.
One of the ways people respond to threats is to find alternatives to technologies. And we did a story some time ago about advanced electric machines, which got to make certain I get the name right. They're making switched reluctance motors for electric vehicles. Now, switched reluctance motors have been around for, since the 1800s, but they've always been noisy, unreliable, and it's hard to make them work. But they've found ways to do it, and that means that they can make electric motors without permanent magnets and make them cheaper. I'm wondering if that is something that, obviously at a national point of view, we've got to welcome new technologies being developed. AEM's up in Newcastle. But I'm wondering what your thoughts are about the way that technology may find ways around using permanent magnets.
Okay, well, as you say, the switch reluctance technology has been around for a long time. There's no doubt it is being improved. There's actually no doubt it will be used in certain electric vehicle applications. I think the latest BMW actually has two motors. One is a switch reluctance motor, and one is a rare earth based permanent magnet motor. And that's probably how we see technology like that coming up. It will come in, it will be used in some cases. However, provided the geopolitical aspects of the rare earth supply chain can be adequately addressed, I would still say that most of the motors that go into a drivetrain will be rare earth permanent magnet based, simply because they are better than anything else from a technical point of view. Of course, as we say, if the geopolitical factors are brought in, then you've got to weigh up technical superiority versus supply chain disruption issues, and that's where you may see a greater uptake in alternative technologies.
Yeah, it strikes me. I fully take the point. I mean, the difficulty is, of course, that the unpredictability of the geopolitical situation is such that, again, if I was in government, which happily I'm not, I'd be looking to promote ways of encouraging innovative ways around permanent magnets, just in case the hits the fan.
Okay. Well, I think you pursue both courses, wouldn't you? You do look at innovation, but at the same time, you look at what you can do to secure sources. And a very often quoted cliche is that rare earths are not rare. If you look at, you can just Google crustal abundance of elements, you'll see a graph, and you'll see that the rare earths, even those used in permanent magnets, they're relatively abundant compared to elements that we're a lot more familiar with. And even some people will say, well, hang on, you need some pretty obscure rare earths, like terbium and dysprosium in your magnets. And yes, you do, but even they're more abundant than certain of the metals that we're a lot more familiar with in our everyday life. So So it's all relative. It is more a case of trying to make sure that these prospects that are out there, particularly the ones in friendly jurisdictions for us, Australia, North America, they are able to get off the ground, get up and running, and they're able to supply economically. And at the point we have a more balanced supply chain, then the concern about geopolitical issues becomes less of an issue.
I should have asked you this question right at the beginning, because I do know that rare earths are not rare. Why are they called rare earths?
I think it's because they should have been called the hard to identify earths, and yet the person who named them thought that was a bit of a mouthful, so we just called them rare.
Okay, anybody else got any more questions for Ian? I'm understanding this, or getting to understanding this is absolutely brilliant. Roy, please, yeah.
A little bit of a historic question, actually. Original work on some of the rare earths was done at Harwell. And correct. In my youth, I worked at the German equivalent of Harwell, the Kernforschungszentrum near Karlsruhe. And although the main objective was actually developing fuel elements for their fast breeder reactor program, which is no more, one of the things I worked on was the thermal conductivity of lanthanum oxide. I'm just wondering, why did it all come out of that area? Because I've never actually managed to get to the bottom of that, and I've forgotten why I actually was measuring the thermal conductivity of lanthanum at the time.
I'm really glad you didn't ask me why you would be interested in the thermal conductivity of lanthanum oxide, because I haven't got a clue. Well, I suppose it's fair to say I don't know for certain. I'm probably younger than I look, so I wasn't around. But two possibilities I would give you. One is that some of the technology developed in the nuclear industry, particularly things like solvent extraction, are very applicable to rare earths. So maybe people, as they were developing the technology, felt it was useful to look at how it worked for rare earths. Another point, of course, is that the kind of elements of interest to the nuclear industry, the actinides, uranium, plutonium, thorium particularly, they occur, say, in that little row of that block that's never really, no one ever wants to put in the periodic table, that block at the very bottom that often appears in the appendix, and the rare earths appear on the row above it. In practice, that means that most of the minerals which contain rare earths also contain radioactive elements. So if you I go into the history of how rare earths ever landed in northwest England and witnessed at rare earth products. The original processing that was set up there in the 1950s was to recover thorium from a mineral called monazite. And that went on quite a long time through the sort of late 50s and early 60s, with the idea being that thorium was a potential nuclear fuel material. It's a radioactive element that can be used as a fuel. Now, monazite happens to be one of the main minerals that's still processed today to produce rare earths. So as the company in Widnes, which is called Thorium Limited, was processing all its monazite, it was generating loads of rare earths, which is what led to the formation of a company called Rare Earth Products. I think the people naming companies then, they didn't have a lot of imagination. There. Thorium Limited and Rare Earth Products, they did exactly what they said on the tin. And so that could give you some link of associating the nuclear industry and between rare earths, but also in terms of nuclear processing, and I have to go, because when I first got a proper job, it was the Atomic Energy Authority and on the science side, so I know a bit about this, is that in nuclear fuel cycle, you often add a moderating agent, something which slows down the rate of the nuclear reaction. And common ones that are used are rare earths, particularly the rare earth gadolinium. So you probably find that rare earths were used quite a bit in the nuclear industry in one form or other. So there are three reasons. I'm afraid I can't answer your question directly, but I can give you three possible reasons why the nuclear industry had an interest in rare earths.
Thank you. And I apologize in part the question, but I'm a lapsed metallurgist by training. So that was hence the reason for my question.
Lapsed metallurgist, heavens above.
Laps done on frock is what I normally say.
Anybody else got any more questions for Ian about anything to do with that? I'd have to say, you talked about, and we've discussed this quite a bit, Ian, about this, auditable supply chain labeling of products, consumer consciousness, and all of that across a range of stuff. And usually, somebody says, well, for as long as people are going in, buying a T-shirt from Primark, wearing it and throwing it away, for as long as that's happening, we're going to remain in trouble. But I'm wondering to what extent developing labeling, which does ask the questions, do you know where the bits coming from, would be seen as protectionist, because again, for instance, we have a business secretary who is a avowed free marketeer, and most of the cabinet are avowed free marketeers. They probably, they'd rather kill themselves than allow any form of protectionism to come into place. Do you think it's possible to get labeling in place? And I throw that open to anybody, but Ian, while you raise the issue.
I think it's essential to have auditing in place and for us to have traceability. And before we talk about recycling, one of the concepts when we talk about design for recycling is to actually have a barcode somewhere on a component which can be read by the right person. You give the complete history of it's more for the chemical composition, but why can't you have a barcode that actually gives you the ethical history, and that has Ernst Young been in and audited that supply chain and verified that it's ethical, and I wouldn't see that as protectionism at all. I'd see it as essential. We want to, we all like to think that we're all citizens of planet Earth. I don't think any of us are comfortable with the idea that one of the things that helping us in our quality of life has been, developed in some really unpleasant circumstances, and people's quality of life has suffered as a result of that. And I think you have to be pretty rabid to consider it protectionism, just to sort of give the consumers more information about supply chains for the products they use every day.
You may say rabid, I couldn't possibly comment. But of course, you're absolutely right. We now have the Modern Slavery Act, and companies have to make statements about that. And companies are also being expected to make, I forget, is it ESG? I forget which acronym to use that replaced CSR.
ESG is the main one, environmental and social corporate governance.
Yeah. And they're having to make those statements. So in fact, it's really not much of a stretch to start expanding that in the way you suggested.
Yes. Yeah.
Anybody else got any thoughts on that? Any rabid protectionists? Rabid free marketeers in the group? I suspect not, but there we go. Andy Dorset. Andy Dorset. Sorry, I was going to put Andy on the spot, but Randy. Okay, Andy Dorset. I'm wondering, because you very much are in the consumer goods industry. Does any of that resonate around sourcing?
It does very much so. I mean, it depends. I guess it depends very much on the product that you're selling. But there's certainly some products that we sell, like Pampers, for example, where indeed the 2D barcode, and the traceability of the source of cotton, even back to the field where the cotton was grown and the name of the farmer. So, it just to kind of give consumers confidence in terms of, what are they getting and where are they buying it from. So it's a very interesting point, because indeed, from everything you've said here, which has been a fascinating conversation, I know nothing about rare earth metals, I'll be honest, but listening to your industry and the competition you've got with China, and how do you find maybe those innovative approaches to kind of change the industry and stay ahead and still be able to compete? I think it's a huge challenge, but I think you've got to give. If you can give consumers, or whatever they're buying, a car, a phone, or whatever, and you can show how that's being ethically sourced, maybe that's an interesting angle, just to kind of trace it all the way back to, did you know your magnet came from somewhere in China, or it's coming from Europe? I mean, I'm quite interested to hear what you said about the Horizon 2020 funding and getting a supply chain set up in Europe, because I think if you could build something around that using novel processes, and then the sort of certification and traceability linked to, by the way, this is coming from Europe and not from China, I think that could be a very, very interesting angle.
Thank you.
But
Ram,
not easy to do.
Ram, you put your hand up. No? No. Okay. Well, listen, it's 4 minutes to 7 o'clock, and we all know what that means. It's time to say goodbye. Ian, I cannot thank you enough for joining us today. And Georgia, thank you so much for making this possible. I should say that Adrian Warren, who did some work with you guys on photography, he's the one who put Georgia in touch. And I'm very grateful, because I think it's been an absolutely fascinating discussion, and as always, enlightening, and taking us down paths none of us, or few of us, knew existed. So Ian, thank you very much indeed. Thank you all very much for being with us. Appreciate it as always. I know that Ram is probably looking at the cricket while we've been on this, and I'm desperately hoping, oh no, are they still only 2 down? Oh, heavens above. Okay, yes, there we go.
Oh no, VK is out. VK is out for you. There you go.
Oh, VK, oh, is he? Okay, well, yeah, there we go. Anyway, it's funny how conversations in like there's always tend to either stream into discussions about wine or cricket at the end of the the evening. So there we go.
Very good.
Thank you all again. Thank you for being on Kaizen Central. From us at Manufacturing TV and Less Common Metals and everybody else, thank you so much for being with us. See you next time.